You know, if you want to find the real practical frontier of AI today, you don't look at chatbots writing poetry. You look at something really mundane. You look at washing a greasy frying pan.
Right.
Or, and this is the ultimate test, you ask a robot to open one of those super thin plastic dog poop bags.
Ah, the worst.
It's the seemingly simple physical thing that's still the ultimate humbling challenge. It just shows you the gap between the digital world and the physical one.
And welcome to the Deep Dive. We take your sources, your research, and we pull out what really matters. Today, it's all about applied intelligence, AI in the real world right now.
Okay.
So we're going to unpack three key areas. First, we'll look at the latest robot Olympics and a really big training data breakthrough.
Okay.
Then we'll get into some new utility tools that are really speeding up daily workflows for creators. And finally, a new open source AI agent that's, well, it's seriously challenging the big players.
Okay, let's unpack this.
So we've all seen those videos, right?
Glossy demos.
Exactly. Robots dancing, moving boxes perfectly. It looks incredible in a lab.
But the real world is messy.
That's it. Friction, gravity, a self-closing door. That's where those demos just fall apart.
And that's exactly why this new Robot Olympics from PI is so important. It forces them into these ridiculously hard, real-world chores.
And we're not talking about simple pick-and-place tasks. Think
Yeah.
about the complexity here. The robot, point 6, had to get through a door with a lever handle.
Which requires that perfect sequence of pushing down and pulling.
Right. And it had to insert a key into a lock. And then the big one, wash a greasy pan with soap. You've got fluid dynamics, tactile feedback. It's all incredibly hard for a machine.
And the results really show where the rubber meets the road, or I guess where the gripper meets the fabric.
Yeah.
It actually managed to turn a sock right side out, but then it completely failed trying to do a shirt sleeve. The geometry was just too complex.
Exactly. And the sources said the single hardest task was opening that thin plastic bag.
The dog poop bag.
That one. The material is so thin and reflective, it literally blinded the camera sensors mid-move.
Wow.
It's a classic perception problem mixed with a dexterity problem.
Yeah.
It's a fascinating failure, really.
But what's really fascinating here is the shift in how these robots are being trained.
Yes.
It used to be thousands of hours of expensive robot-specific demos.
Yeah.
You know, watching other robots do the task.
We're moving past that. The breakthrough is that the fine-tuning was done on egocentric human video.
Okay, so define egocentric video for us.
It's just first-person footage,
Yeah.
like a GoPro on your head while you're doing the task, making coffee, folding laundry, whatever.
So the robot is learning by watching us.
Exactly. It's a cheap, scalable data source.
Mm-hmm.
And the robot isn't just learning how a robot moves, it's learning the intent behind human movements. So it generalizes way faster.
This whole process is a little like learning to drive just by watching dash cam footage. And honestly, I still wrestle with prompt drift myself when I try new AI systems. So seeing a robot learn this complex physical skill is just, it's incredible. So if these human videos are the key, what's the bottleneck? What's preventing these robots from being in every home folding our laundry right now?
Repeatability across many different unpredictable real homes is still the primary missing piece.
Right.
So, yeah, the physical world is still a huge challenge.
Right.
But the digital world, that's where AI is making these immediate, massive efficiency gains.
Right. Away from the hardware problems.
We always focus on the huge models, but the daily utility stuff, that's where AI is saving people hours of tedious work.
And the sources pointed to a few of these. Let's talk creative efficiency. They compare models like GPT Image 1.5 with another one, Nano Banana Pro, for people making ads or thumbnails.
And the huge win there is being able to edit photos directly inside something like ChatGPT.
Okay, so you don't need a separate app.
No more exporting, opening Photoshop, making a change, saving, re-uploading. You just type what you want.
That avoidance of app switching that's probably the biggest convenience win right there for anyone creating a lot of content.
It really is.
Yeah.
And beyond visuals, there are these document and video tools. Take one's called Typeless.
Okay.
It's designed to take your spoken words, your messy brainstorm in a meeting, and instantly turn it into a polished document, like it was perfectly typed.
So it turns a chaotic brain dump into a clean memo instantly.
Yeah.
That's a massive time saver.
And then there's EgoX. This one is really wild. It can take any third-person video, like a movie clip.
Like from The Dark Knight or something.
Exactly. And
Yeah.
it converts it into a first-person point of view version.
Wow. I can see that being huge for training or immersive storytelling.
For sure. And we can't forget the visual Swiss Army knife, Nano Banana Playground.
Right.
It does text-to-image, image editing, and this is key. It handles multiple aspect ratios really well. No more weird forced crops.
The sources also mentioned a system for recycling old content, right? Like turning forgotten blog posts into new traffic.
Yeah, another example of AI just streamlining workflows, making the most of what you already have without hiring more people.
So out of all of these, which tool offers the biggest immediate time saver for just a general professional user?
Using in-chat photo editing, avoiding app switching is truly the biggest convenience win.
Okay, so the digital world is getting more efficient, but what about the really big, complex tasks? This is where it gets really interesting. There's this new open source model, MiniMax M2.1,
Right.
and developers are already calling it a Claude killer.
That's some high praise. But before we get into why, let's just quickly define what an AI agent is in simple terms.
Right, good idea.
An AI agent is a program that plans, acts, and then corrects its own mistakes to finish complex tasks.
Okay, plans, acts, corrects. Got it.
And M2.1 was built from the ground up to do just that. The performance numbers really do back up the hype.
Let's talk about those numbers. It scored 72.5% on something called SWE multilingual. What does that percentage actually mean?
So SWE Multilingual tests the model's ability to fix bugs in open source code autonomously. So that 72.5% means it can find, diagnose, and fix a huge number of real-world software bugs with zero human help. That actually puts it ahead of some big proprietary models like Claude Sonnet 4.5.
And then there was the 88.6% on VibeBench.
Right, and VibeBench measures how well the agent can interact with user interfaces.
Like navigating a website or a phone app?
Exactly. It's like having an AI that can beta test your software or make complex design changes on its own.
Whoa. Imagine scaling this planning accuracy to handle 1 billion complex database queries autonomously. That level of reliability, that changes everything for big companies.
It absolutely does.
But with that kind of self-correcting ability, how much power does it take to run? Is this something that's even sustainable outside of, a huge tech firm?
That's the right question. And the key is its agent-native design. Most older models, they just follow a list. Step 1, step 2. If anything changes, they fail. They just stop.
Okay.
M2.1 is different. After every action it takes, it looks at the result, and if it needs to, it revises its plan. It corrects its own mistakes on the fly.
So it basically debugs itself.
That's a great way to put it. And because it supports languages, developers actually use Rust, Java, Go. It can build real full-stack apps.
So it's not generating what they call AI spaghetti code.
Exactly. It's clean, structured code. The sources say it's holding up incredibly well even against older top-tier models like Claude 2.
So if M2.1 is open source and performs this well, what's the biggest barrier stopping everyone from just adopting it over the proprietary models?
Accessibility and scaling infrastructure remain the main challenges for any open source alternative.
Okay. So if we pull back and look at everything we've covered, there's a pretty clear narrative here connecting the physical and the digital.
We went from robots learning to wash pans by watching human videos.
That egocentric learning.
Right. All the way to AI agents that can debug their own complex digital plans.
And the theme that connects it all is leveraging human knowledge, our videos, our code, our old content, all to build systems that are more adaptive, more reliable.
Yeah, the frontier isn't just raw intelligence anymore. It's autonomous adaptation.
That's really well put.
And if we connect this to the bigger picture, we've talked about these new ways to organize and create, all driven by agents that can revise their plans instantly. And that raises a pretty important question for us, I think. If AI agents get this good at revising their plans mid-task, how much of our own mental workflow, our human reliance on static linear plans, how much will that need to adapt to keep pace?
A good question.
What if, in this new age, failure is just the essential first step in a successful self-corrected plan?
Something to mull over as you optimize your own workflows.
Thank you for sharing your sources for this deep dive. We appreciate you joining us.
Until next time, stay curious.